Okay, so I wanted to go over 6.2 number 39. It's this problem right here. It says find the volume of the solid that results when the region enclosed by y equals square root of x, y equals 0, and x equals 9 is revolved about the line y equals 9. Okay, so y equals square root x, y equals 0, and x equals 9. And oh, that's interesting. So we're revolving around the line x equals 9. Okay, so let's take a look. So we've got so y equals square root x. If I go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my axis of rotation, right? So I'm going to be revolving around that line. But y equals square root x goes through 0, 0, 1, 1, 4, 2, and then 9, 3. So it's kind of this half parabola thing, right? Excuse me. So we're interested in the region bounded by this curve, the line y equals 0, which is the x-axis, the line x equals 9, which is this dotted line here. So it's this region in here. So it's this stuff in here. And we're going to revolve it around this line. So around the line x equals 9. Excuse me. So I'm not going to attempt to draw the three-dimensional figure. What we need to kind of determine is if we're going to, so this was from 6.2, right? So in 6.2 we did the disk washer method. So if we're going to try to solve this using disks and washers, then we need to figure out which way to slice it so that we get disks and washers. Now imagine, so just try to picture in your mind rotating this around, and then if you slice it this way with respect to the x-axis, or like slice it along the x-axis, or slice it parallel to the y-axis, I guess I should say. So take these vertical slices, you're not going to get discs, right? You're going to get these weird kind of shapes. So we have to slice it this way, across horizontally, right? If we slice it horizontally, then we'll get these nice discs. And so in order to find the volume of that region, we need to find the area of each disk. Finding the area of each disk is just a matter of doing pi r squared, right? The area of a circle, pi r squared. So really the difficult part here is figuring out, well, what is the radius of any given circle? So you take any given cross section of this three-dimensional figure and you have to figure out what is the radius there. Because if you have the radius, you can find the area, and if you have the area, well, then you can find the volume, right? You can just add up all those individual areas. So let's just imagine, right? Let's just imagine, since we're slicing horizontally, let's imagine that this is the horizontal slice, and I'm just going to call this thing y. Okay? Well, let's imagine that you take this horizontal slice here, okay, and we want to know what is the radius. So again, you're rotating this around this line. So you would get this. This would be the radius of that kind of completed circle, I guess. So so what is that distance? Well, we know that from here to say here, we know that this distance right here should just be, well, if this is the curve y equals square root of x, then if you solve that for y, you see that x equals y squared. So this is y squared, right? This is y squared right here, which means this distance is y squared. But that doesn't help us because we're trying to find the radius, this distance here. Well, if this distance is y squared, and if this whole distance is 9, then that means this little distance here, which is the piece we're looking for, should be 9 minus y squared. And there you go, right? That's the radius of any given sort of horizontal cross-section that you take. The radius is going to be 9 minus y squared. Well, so we're ready to set this thing up then, right? We would say, so the volume is going to be the integral. Now we're going to go from 0 to 3, right? From y equals 0 to y equals 3. So we're going to go from 0 to 3. of pi times the radius, 9 minus y squared, squared. So there you go, pi r squared. So we're going to find the area of each disk. At any given cross section, the area of the resulting disk is going to be pi times 9 minus y squared squared. And then we're going to find all of those areas, and then we're going to add them up. And that's essentially what the integral does, right? So dy. The rest is easy. I think the setup is the hard part, but the rest is easy. The way I would integrate this is, move the pi outside the integral sign, and then expand the 9 minus y squared squared. So write it out twice, FOIL it. You're going to get 81 minus 18y squared plus y to the fourth dy. And the rest is history. So I'll leave the rest to you. But that's, again, this. Oh, what number was this? This was number 39. So this was, this was 6.2, number 39. Okay, so hope that helps on that one.